This week we are going to be studying linear functions. And linear functions are one whose graphs are a straight line, and they can always be written in the form y equals mx plus b, where m is the slope and b is the point where the line crosses the y-axis, or some people call that the y-intercept. Now, hopefully you can remember maybe from middle school or a while ago that slope is rise over run, or another way to say it, it is the change in the y values divided by the change in the x values. So you look at how far you have moved up on your y-axis versus how far out you have moved on your x-axis. To determine if an equation is a linear equation, you look at the power on the x term. Any power that is 1, let me get back to my page, any power of 1 means that it is linear. For example, if you have y equals 3x minus 2, and you're wondering, is that linear? Well, you look at the power on your x term, and hopefully most of you know that if there's no power indicated, that it is 1. So you say, yes, that is linear. In this function, 3x plus 2y minus 1, is that linear? Well, we're not sure, but if we get it in the form y equals mx plus b, you can see that our x power is 1. So yes, it is linear. Is y equals 2 minus x squared over 2 plus 5x linear? No, there is an x to the first term component, but there is also an x squared. So that means it is not linear. Y equals the square root of 2x plus 1, is that linear? No, because it has the square root of x in it. And then y equals 2x plus the square root of 17, is that linear? Yes, because the x has a power of 1. So, let me get rid of this. So the slope is the change in the y values over the change in the x values, where x2 and y2 are 1 point on your graph, and x1 and y1 are 1 point on your graph. So if we have 2 points, such as 2 and negative 3 and 5, the point 5, 5, we can make either point 0.1 or 0.2. It really doesn't matter as long as you keep them together. If you make this 0.1 and this 0.2, as long as you keep that x and y together and this x and y together, it doesn't matter which one you use as 0.1 or 0.2. So let's make 2 minus 3.1 and the 0.55, let's make that 0.2. So to determine the slope, it's y2 minus y1. Well, y2 is 5, so we put that right there. y1 is negative 3. We put that right there. Please note that it's y2 minus y1. So in this case, it was y2 minus a negative 3. And then x2 is right here, which is 5. And x1 is right here, which is 2. So it's 5 minus 2. And we find that our slope is 8 over 3. Now, if you just want to have a little bit better comprehension and you say, well, what if I made my points, if I identified the points the other way? Will it still work? And the answer is yes. So let's make 5, 5.1 and 2 minus 3.2. And when you go through this same exercise, you will see that you end up with negative 8 over negative 3, which is just 8 over 3. And these 2 points are, in fact, the same thing. Now, slope can be either positive, negative, 0, or undefined. A positive slope looks like you're going uphill. A negative slope looks like you're going downhill. A 0 slope is horizontal, meaning there is no rise over run. So if this is 0, you can see it's just a horizontal line. Or an undefined slope, which is any run over 0, any rise over 0 run, you're dividing by 0, so that becomes undefined. Now, there are two ways to write the equation of a line. There is the point-slope formula and the slope-intercept formula. And we're going to use both of those sort of interchangeably this semester. The point-slope formula is written y minus y1 equals m times x minus x1, where once again you can assign either point to point 1, and m is going to be your slope. M is always the slope. Now the slope-intercept formula, let me try to get rid of this line right here. Kind of messed up your notes and I don't want that. The slope-intercept formula is y equals mx plus b, where m is the slope and b is the y-intercept like we just talked about. So let's say we have the problem, find the equation of a line with slope of 2 and y-intercept of 3. Well, since you know the slope and the y-intercept, we can use the sloped-intercept formula of a line and merely fill in the m and the b component. So it's y equals mx plus b, where m is 2 and b is 3. And we're all done. So that's all we need. But let's say we are given a point and the slope. Find the equation of the line passing through this point with slope of negative 2. Well, now that you know a point and the slope, you're going to want to use the point-slope formula, which was y minus y1. Let me write it out again for you. Y minus y1 equals m times x minus x1. So you can see y1 in this particular problem is 4, m is negative 2, and x1 is 0. So when we fill this in, we have y minus 4 equals negative 2 times x minus 0. Y minus 4 equals, distributing this over, you have negative 2 times x, which is negative 2x. Negative 2 times 0 is just 0. And then we can move this negative 4 to the other side by adding 4 to both sides. So if you add 4 to this side, you're just going to be left with y. And you will have minus 2x plus 4. That is our final answer, and we are done. We can put a happy face on it. Now, if you are given 2 points, you can also use the point-slope formula, because we learned that if you're given 2 points, you can calculate the slope. And again, it does not matter which point you use for point 1 or point 2. So in this problem, it says find the equation of the line that passes through 1, 3, and 0, 5. Let's let 1, 3 be point 1, and let's let 0, 5 be point 2. So if we have y2 minus y1 over x2 minus x1, these are my y's, and these are my x's, and we're going to let this be 1 and this be 2. So it's going to be 5 minus 3 over 0 minus 1, which is 2 over minus 1, which is negative 2. That's my m. Now we can choose either one of these points and combine it with this m to write our equation. And let's say we're going to use the first point, 3 and 1. So we'll have y minus y1 equals m times x minus x1. So this is our y, and this is our m, and this is our x using the point 1, 3. So we're going to have y minus 3 equals minus 2 times x minus x1. Y minus 3 equals minus 2x plus 2. Adding 3 to both sides, we have y equals minus 2x plus 5. Now, if you just want to prove to yourself that it doesn't matter which point you use, we've done it again using the point 0.5 over here on this side. And we said or. We can say y minus 5 equals minus 2x minus 0. Y minus 5 equals minus 2x plus 0. Adding 5 to both sides, we have y equals minus 2x plus 5. And you can see that they do equal the same thing. Now let's look at an application. Let's say we have water in a rectangular fish tank, and we want to determine how long it's going to take to fill the tank. After 4 minutes, you have 7 inches of water in the tank. So you know you have the point 4 minutes and 7 inches. That tells you after 4 minutes you have gotten 7 inches in the tank, and we're going to assume this is a linear relationship. If the tank is 12 inches tall, how long is it going to take to fill the tank? Well, we know we have 2 points. We have the point 0, 0, because that's where we started with an empty tank. And we have the 0.47 because we knew that after 4 minutes we were 7 inches. So let's calculate our slope. Again, that is y2 minus y1 over x2 minus x1. And that's going to give us 4/7. So with our line, we know the y-intercept is 0 because we started at 0.00. So the equation of our line, we can use our y equals mx plus b formula. So we know y is going to be 7/4 x plus 0, or it's just 7/4 x. From our problem, we know that the depth was 7 inches at 4 minutes. So 7 is our y value and 4 is our x value. If we want to know how long it's going to take to fill the tank to a full 12 inches, then we can say 12, which is going to be our y, is 7/4 x, where x is our time. And then we can multiply both sides by 4/7, because if you have 7/4 x, and if you multiply it by 4/7, that's going to just equal x, because 7 over 4 times 4 over 7 is going to give you 1x. And if we multiply 12 times 4/7, we have 48 over 7, which is x. So it is going to take you 48 over 7 minutes, because remember our units in this problem were minutes, or 6 6/7 minutes to fill the tank. With that, I would like for you to look at the exercises on page 16, numbers 1 through 7, and let me know if you have any questions.